Hello friends, welcome back. This is Himanshu Verma. Till now we have got basic idea of displacement, velocity, acceleration and force. We have solved some straightforward problems also based on these terms. But sometimes we encounter complicated problems. Complicated problem means the problem where more than one object is in motion and those have different acceleration in different direction. So these kind of problems are little difficult to manage without knowledge of vector. So before proceeding further, we take some knowledge of vectors. For understanding purpose, we can take this example. Suppose this is an inclined plane on which a box is sliding. And now suppose this whole system means inclined plane and box start moving with an acceleration A in forward direction. So in this case, the sliding acceleration of box on the inclined plane will change. So these kind of problems can be solved very easily by using vectors. I have already made a video in which I gave the solution of this problem. If you want to see that, then you can find the link of that video in description box. Now we get some knowledge about vectors. We all know definition of vector quantity. Those quantities are vector quantities which have both magnitude and direction. Suppose we take example of force. If I say I apply a force of 5 Newton, then in physics this sentence is incomplete. I also have to mention in which direction I applied this force. If I say I applied a force of 5 Newton in this direction, now this sentence is complete. This arrow is showing the direction in which force is applied, and this 5 Newton describes the magnitude or strength of the force. Similarly, if I say I am moving with the velocity of 5 meters per second, then again this sentence is incomplete because I can move in any direction with this velocity. So I have to mention direction also. If I say I am moving with the velocity 5 meters per second in this direction, now this sentence is complete. Here this arrow is showing the direction in which I am moving, and this 5 meters per second represents the magnitude of velocity by which I am moving. Similar example we can take for displacement also. Suppose I say from this point I have traveled a displacement of 1000 meter. Now again this sentence is incomplete because you did not provide direction in which that 1000 meter is traveled. Now if I show like this, then this make a sense. It shows I traveled a displacement in this direction and magnitude of displacement traveled is 1000 meter. Now again, if I look at these three examples, then these give a complete knowledge about vector quantity. In these examples, I have randomly given some direction, but do they make some sense? Here, I just marked an arrow and saying I am moving in this direction or I am applying force in this direction. But what is this direction? You have to give some reference so that you can identify that direction. If you want to identify any direction, then you have to provide its angle with some reference line, and generally that reference line is taken x-axis. Now if we remind this force example, then I would say I apply a force of 5 Newton and the direction in which I applied force is at 30 degree with positive x-axis in anti-clockwise direction. Now I have complete idea about strength of force and direction of force. Now if we reconsider example of velocity, then in this, suppose this angle is 210 degree. So now this is complete information. Magnitude of velocity is 5 meters per second and its direction is at 210 degree angle in anti-clockwise direction with positive x-axis. Similarly, we can remind example of displacement. Suppose this angle is 150 degree. Then we will say we have traveled a distance 1000 meter in a direction making an angle 150 degree from positive x-axis in anti-clockwise direction. Now after going through all this, we can say this is very appropriate way to represent a vector quantity, because in these examples we are showing magnitude as well as direction of application. Now question arises, is there any another way by which we can represent a vector quantity where we don't need to mark these kind of arrows? So its answer is yes. We can represent this force vector as 5 angle 30 degree, this velocity vector as 5 angle 210 degree, this displacement vector as 1000 angle 150 degree. So if I represent in this way, then I don't need to mark these arrows. Actually this is very confined way to represent a vector quantity, but its drawback is we can't do subtraction, addition or multiplication of vector if we represent vector quantity in this form. Suppose I say I apply a force of 10 Newton at 30 degree angle and I apply a force of 5 Newton at 30 degree angle. So what is the net force? So net force would be 15 Newton at 30 degree angle. But if I say I apply a force 10 Newton at 30 degree angle and 5 Newton at 20 degree angle, now what would be net force? Now I can't add these 10 and 5 because angle of applications are different. Now question is how to add it. If we want to add these two vectors, then we have to find some another way to represent a vector. So now we find that way, means how to write a vector. We take same examples one by one. This is first example of force. As we know, any vector quantity has two information. First one is magnitude and second one is direction. In previous example also, we used same way. Here 5 is magnitude and this 30 degrees direction. Here 5 is magnitude and this 210 degree is direction. Here 1000 is magnitude and 150 is direction. So it is very much clear that any vector quantity has magnitude and direction. Now we will write any vector quantity in multiplication of these two, means magnitude multiply by direction. Now if you already have written magnitude here, then this direction term should not contribute any magnitude because you are multiplying these two, and if this direction term also contribute magnitude, then on multiplication overall magnitude will change, which we don't want. So we will emphasize that this term should only provide direction and unity magnitude, because if this term provide unit magnitude, unit means 1. If this term provide magnitude 1, then on multiplication overall magnitude will not change. That's why this term is also known as unit direction term. So we can say we will write a vector quantity where we multiply the magnitude with unit direction term. So now our question is how to find this unit direction term. To find this unit direction term, just noted which angle is made by this vector with positive x-axis and positive y-axis. Now if you have found those two angles, that is with positive x-axis and positive y-axis, then take cosine of these two angles. Suppose any random vector making angle alpha with positive x-axis and beta with positive y-axis. Now take cosine of these angles, so they will become cos of alpha, cos of beta. Because alpha is the angle made with positive x-axis, so put ax cap with cos of alpha, and because beta is the angle made with positive y-axis, so put ay cap with cos of beta. Now our unit direction term is ready. Our unit direction term would be cos of alpha ax cap plus cos of beta ay cap. I wrote this unit direction term for this vector, which is making an angle alpha with positive x-axis and beta with positive y-axis. And suppose this vector magnitude is a, so I will write a vector is equal to magnitude term means a into unit direction term, which is cos of alpha ax cap plus cos of beta ay cap. So this is very easiest way to write a vector. We just need magnitude of that vector, and for its direction we need its angle with positive x-axis and positive y-axis. Now suppose we want to write vector for this force example. Here angle made with positive x-axis is 30 degree. So angle made with positive y-axis would be 60 degree. So our unit vector for this force vector is ready. That is cos of 30 degree ax cap plus cos of 60 degree ay cap. Now multiply this unit vector with magnitude, which is 5 in this example. So for this, our force vector F is equal to 5 into cos of 30 ax cap plus cos of 60 ay cap. Here cos of 30 and cos of 60 are known as direction cosines for this vector. Now we take second example of velocity. Magnitude we know, that is 5 meter per second. Now unit direction we have to calculate. For this, I should know respective angles which this vector is making with positive x-axis and positive y-axis. So this vector is making 210 degree with positive x-axis. Now how much angle it is making with positive y-axis? So this much angle is made with positive y-axis. To calculate this angle, I can subtract 90 degree from 210 degree and I will get 120 degree. Therefore, for this vector, my alpha value is 210 degree and beta value is 120 degree. My direction cosines would be cos of 210 degree, comma cos of 120 degree. And my overall vector would be 5 into cos of 210 degree ax cap plus cos of 120 degree ay cap. Now question is how to get the value of cos 210 and cos 120. If you don't know how to calculate these values, then please watch lecture number 1 video. In that video, I have told all such kind of basics in detail. Here I would like to tell one more thing. When you are finding the angle with positive x-axis or positive y-axis, then you can measure this angle in any direction. Means you can take it in anti-clockwise direction or in clockwise direction. This will does not make any difference in final expression of vector. Reason behind this is because after getting these angles alpha and beta, you are taking cosine of those angles, and in cosine function it does not make any difference whether angle is positive or negative. Again, if we take third example, that is example of displacement, then in this angle made with positive x-axis is 150 degree and angle made with positive y-axis is 60 degree. So direction cosine would be cos of 150 degree, cos of 60 degree, and vector would be s cap is equal to 1000 into cos of 150 ax cap plus cos of 60 ay cap. Cos of 150 and cos of 60 value you can find. And if you don't know how to find these values, then please watch lecture number 1 video. So in this way, you can write any vector. In vector representation, sometimes we use I cap and j cap at the place of ax cap and ay cap. Suppose now we want to add two vectors with different angle, means with different direction. Suppose we want to add 10 angle 30 plus 20 angle 60. So directly we can't add them, but if we write these two vectors in proper vector form, means in terms of ax cap and ay cap, then we can add them. If I solve it, then this 30 degree angle is with positive x-axis, therefore with positive y-axis angle would be 60 degree. So direction cosine would be cos of 30 degree, comma cos of 60 degree. Now vector would be magnitude term, means 10 into cos of 30 ax cap plus cos of 60 ay cap. And if we solve this, then it becomes 10 into cos of 30 value is root 3 divided by 2 ax cap plus cos of 60 value is 1 by 2 ay cap. If we solve this further, then it becomes, if we take 10 inside, then it becomes 5 root 3 ax cap plus 5 ay cap. So this is first vector. Suppose this is vector A. Now we find vector B. Again, its direction cosine would be cos of 60 degree, comma cos of 30 degree. This time 60 degree is the angle with positive x-axis and 30 degree is the angle with positive y-axis. So vector would be 20 into cos of 60 degree ax cap plus cos of 30 degree ay cap. If we solve it further, then it becomes 20 into cos of 60 1 by 2 ax cap plus root 3 divided by 2 ay cap. Further it becomes 10 ax cap plus 10 root 3 ay cap. Say this is vector B. Now we want to add these two vectors. For addition, the component in x direction for both vectors would be added and component in y direction for both vectors would be added. And final result would be 10 plus 5 root 3 ax cap plus 10 root 3 plus 5 ay cap. So this is the expression for a plus b. You can also see this is the resultant vector of a and b. So friends, in this lecture we stop here. In this lecture we learned how to write a vector. If you start knowing this thing, means how to write a vector and what is the meaning of vector, what is the meaning of vector quantity, then it would be very easy for you to understand physics. In next video we will see what is the meaning of product of vectors. Please like and share the video and subscribe the channel. If you have any doubt, ask in comment section. Thanks for watching. Goodbye.